we started in 1975 in Hinwil. So this year we are celebrating 50th year anniversary. And then there are so many milestones. Because I have a little bit more topics to cover, some of the slides I will just fast forward. We listed on the Swiss Stock Exchange in 1995, and we invest around 7% of our revenue in the research and development. So just wanted to make sure that this is the revenue and not the profit. So 7% of the revenue. Well, with this we started with damper actuator, then some of the control valves and sensors and meters. These are the products over which we have built the trust with customers in last 50 years, and will continue to do so. Usually Belimo finds its application all across the building wherever HVAC is there. But let's talk about a data center, as this forum is focused on data center. Heat rejection at chiller, we have several products for control valve and sensors. Cooling and distribution units, we have some pressure independent valve if data center has. Chill water systems, we have some butterfly valves and control valves. Immersion tanks, we have our products for regulating the flow. We also have air-based cooling, so which traditionally has been there. So we have a sensor assortment to offer, and then there are other products which we have to offer. So that's brief about where Belimo finds its application in the data center. Let's quickly jump into the data hall. So consider this as a data hall. I'm saying consider because this is not how actual data hall. There are so many other things along with this, but these are some of the servers which are installed in the data hall, and those are powered. So when data center is up and running, so what happens when heat density changes? So once racks are installed and heat density is changed. So let's take a look at this is the current occupation or of the co-location or maybe a data hall. This is how the server racks are installed inside the data hall. Then they are up and running, creating some heat. Then there is an occupancy with few more servers in the data hall with additional heat. Then there is an occupancy of few more server with additional heat, and then existing server start generating heat. Existing server again generates some heat, and end of the day, entire data center generates enormous heat. The question is why? Why this heat is being generated? So much of heat into the data center. Well, if you are from the data center, you know. But I'll take few moments to just deep dive or just touch and go on the topics. So to understand why this generates a heat, we need to first understand, or we need to first scratch the surface of the AI market, which is artificial intelligence. There are some pointers with some background or with some references. Over 64% of business owners believe that AI will increase the productivity in their businesses. 62% of them are believing that it will help them to improve the customer relationships, and that's where they are heavily dependent on AI. The another point or another dimension to it is 50% of mobile phone users across the globe are using AI-powered voice searches for their daily routine uses. This is most interesting and known to all of us. ChatGPT had 1 million users within the first 5 days of being available. And the recent news in last January was the DeepSeek, which had 33.7 millions of users by end of January. And by now, they have 22.15 million daily active users. Well, this leads to something. So this, if we bring tangibility to this data, this tells us that this market is going to grow, and going to grow by enormous 468% by 2027, and which will become a 407 billion industry. These are just indicative numbers. There will be, of course, the higher side. There won't be any lower side the way things are going, but these are some of the indicative numbers. If we have this kind of load or this kind of usage or this kind of growth in future, what should be the cooling strategy? Do you think the existing cooling strategy of air-cooled servers will suffice the requirement? Well, that's not the 100% yes to that, and that's where the question comes on liquid cooling, which has a capacity or capability to handle the higher loads. So let's explore what liquid cooling is. There are five types of liquid cooling in a data center. First type is rear door cooling, wherein there is a rack and there is a rear door to which the chill water is supplied, and then it exchanges the heat from server to uh, outside the servers. In the second type, it's a cold plate cooling. Cold plate cooling is nothing but liquid conduits or liquid chilled plates which are placed on the um, server racks. We also call it as a cold plate cooling or direct to chip cooling. Third type is phase cold plate cooling, wherein the liquid or the media changes the phase, and that's where the cooling takes place. And the fourth type is single phase immersion cooling, wherein entire server itself will be immersed in the dielectric media. I'm sure other speakers will talk about this. And the last type is same with immersion cooling, but this again has a two-phase cooling in the data center. So these are typically five methods through which the data center is chilled. Let's take a look one by one how we can operate or how things operate there. So this is how the if you're from data center background, you already know this. But if you don't know, this is how the rear door heat exchanger looks like, and there are servers in here, and there is a supply water temperature of 18 degrees centigrade. So this has a capacity of up to 40 kilowatt per rack. And then there is a chill water or dielectric or media, let's call it chilled media, which is being transferred from central distribution unit to the rear door heat exchanger. And then there is a need for control valve, which has the parameter or the benefits of flow and power control. So it regulates how much flow goes, how much power it calculates. Then it also has a delta T management system, energy management, and there are many other benefits. But this is where Belimo helps when it comes to liquid cooling. Coming to the second type, which is a cold plate or direct to chip cooling, this is where the plates are installed on the circuit boards, and these are the chilled water which is being supplied or circulated on these plates in order to keep the semiconductor inside cold. So this has a capacity of up to 300 kilowatt per rack, and this removes up to 60 to 75% of the heat from the semiconductor from the rack. Um, One of the critical example which I want to give here, which includes some of the mathematics, which I'm sure will be of interest to many of you. So this is, let's say, a rack which has four server racks, and this is being supplied with chill water, and then there is a Belimo control valve installed here. There is a feature in Belimo control valve to modulate or control this with the help of delta T or difference of temperature or difference of pressure. And this is one temperature sensor, and another temperature sensor is inbuilt. That's how it calculates the delta T. And then there is a pressure transmitter across supply and return, and that is again connected to Belimo energy valve, which is the pressure independent valve. This is the equation we all know, and then if we convert, so GPM is equal to CV into square root of delta V. It's the standard equation. And let's put some numbers around. So let's say CV is 2.5, which is fixed constant because there is no size or dimension change here. And then there is a delta P, which is differential pressure of 4 psi. So when it comes to a combination of four servers, there are 2.5 is the CV value into number of four servers into square root of 4, which is a delta P. That comes to 20 GPM, and when it comes to three servers, that comes to 15 GPM. So you can clearly see that whenever we reduce the server racks, the flow is automatically reduced. That's the beauty of having this pressure independent valve in place. Again, I will explain you with detailed schematics. So let's say this has a 20 GPM as a supply, and this operates on the temperature difference. It will keep on pumping 20 GPM, but your differential pressure will change across the racks. So for example, in this case, differential pressure is 5 GPM and delta P is 4 PSI. At that combination, you have 20 GPM being supplied. But in the second case, when racks are reduced, delta P is also increased and flow is also increased because your inflow is same. And when racks, sorry, this is racks while decreased, and this is when racks are increased. Again, 20 GPM is the same flow where you can see the different values of flow and pressure. With the current setup, by adding these delta P sensors in the energy wall, we can modulate the flow coming from CDU, whereas flow across the rack and across the pressure difference across the rack remains same. So if you see in all permutation combination, the flow remains same across the rack and pressure difference also remains same across the rack. That's the unique feature that we have to offer for liquid cooling. Third is the two-phase cold plate. I think we can speak about this here. So here you have immersion cooling. These are the server racks which are inserted into dielectric media, and then there are two ways, single phase cooling, wherein again this control wall plays an important role to modulate the flow. And again, in two phase, we have this control wall which plays important role to modulate the flow. So that's all about kind of technologies and where Belimo has its application and distinct features that we can provide. So I'll quickly go through the summary. So we have spoken about broadly air-cooled solution, hybrid cooled, which has air and liquid cooling both, and then 100% liquid cooling. Each has its place in today's market, had its place in yesterday's market, and will have its place in tomorrow's market. So this is where, when it comes to air cooled, we have crack unit, fan wall unit, evaporators, all these things. And when it comes to hybrid cooling, we have passive rear door cooler or active rear door cooler. And in single immersion liquid cooling, we have single phase, two phase, or immersion cooling. So these are the available methods in the industry for data center cooling. If you look at the estimated values last year, that one of the survey we have conducted, so air cooled has, because this is a traditional solution, it has a maximum market share, but this is what the future is going to be. So these figures will be swiping their place, no doubt about that. And if you see in expected value in 2030, the picture is clearly told. The air cooled, we are still keeping some percentage there, because even if you are using the rear door heat exchanger, entire data hall has to be the air cooled. There is no option for that. So that's why we see air cooled solutions will still be there in the system. This is another representation I tried to put about low density up to 10 kilowatt. So up to 25 kilowatt, we can have combination of air cooled servers and hybrid cooled servers. But when it comes to density more than 25 kilowatts, then, or let's say more than 80 kilowatt, liquid cooling, be it be single phase, two phase, immersion cooling, rear door heat exchanger, whichever, or direct to chip cooling, whichever method we talk about, it has its application where the rack density goes up. And if you recollect my presentation at the beginning, we saw that which are the some key elements that why this need will go forward. So even if you like somebody's status on Instagram or some photo on Facebook, that generates a data, and that's how the world is going to be. So I'm sure my fellow speakers will also speak about this, but this is something which is on there on the door. When it comes to the other offerings, let's say I'm again bifurcating this into air cooled and hybrid cooled. In the air cooled, we have all the control wall sensors. So Belimo has a very good sensor assortment to offer when it comes to data center to measure the correct way of correct measurement of the temperature, humidity, or whichever parameter they have to measure. And then dampers are of course there. Control wall is something which regulates or modulates the flow to data hall, not only to data hall but entire data center, and that's where we find the application. So majority all three product lines we see that has an heavy application or utilization in the data center, and there are many more benefits. Those are available, be it be single phase, be it be two phase cold plate, immersion, or liquid cooling.